So the fryer that I ended up working on today, they were complaining that both 2 and 3, so the middle one and the one all the way to the right, were giving heat failure or the question mark in this particular unit. This is a pretty old fryer, but they work really well. What I ended up finding was a little bit different than what I normally find. Normally you do end up with like dirty flame sensors. You just clean the flame sensor with an emery paper or sandpaper or something, and that takes care of it. But in this case I had like corrosion underneath the spot where the wires actually connect to it. So I'll show you in the video. So we're checking these flame sensors. I already cleaned the orifices. They were a little bit restricted, but now you can see a little bit of light through them. To clean the orifices, we just use a tool called a broach, and it just opens up that hole. But if we look on here, you should be able to test from the end of your flame sensor out to here. I already cleaned this up. It was pretty oxidized, kind of like that. And you should get just a closed circuit, a short from here to here. Continuity, that's the word I'm looking for. So there to there, the tool's not registering anything. Should do that. And the other one, right here, this one I'm getting an ohm rating. I'll tell you how many ohms. 122 ohms. So I think these are actually dirty at this connection right here. So we're going to spin this nut off and clean up this nut, washer, and flat piece right here. Put them back together and then see if we can get a proper reading through those probes. That's kind of interesting. I haven't really run into that before, where this connection is bad enough that it's not reading through there. Here's those pieces off of there. You can see they are really dirty. So I'm going to clean these up, put it back together, and then we'll test the probe again. But I'm guessing that's what the problem is. So yeah, with that cleaned up and put back together, that's what we should be getting, is like a closed circuit. So, and like easily. So that's beautiful. We're going to do the same thing to the other one, and then should be good to go. This is how I'm cleaning it, just on some emery paper. Shine up the nut as well, very important. Also replacing the gaskets. I carry some of these with me because the fiberglass gaskets just fall apart. But both of these read really good now. We're going to put them back in and start up the fryer. Another thing to check is make sure that those prongs aren't spread open a little bit. This one looks okay, I think. You just want it so that when you push it on there, it's like good and tight, makes a good connection. And I got those new gaskets in there, so that's looking good. I'm gonna go through the same procedure on this side. Just clean everything up. This is just a 7/16 nut, and you can hold it on the back side with a 1/2 inch to get it broke free. And then there's just 2 1/4 inch screws, one at the top, one at the bottom. They have to come out, and then you can carefully remove it and clean the probes. There we go. And clean those little orifices. Alright. So this one was throwing the question mark previously, but it's all good to go now. Same story with this one here. Just randomly throwing the question mark. There's the model and series in case you're interested. And this is normal. This is what fryers look like out in the field, so don't be freaked out by how much grease there is. This is why restaurants burn down, but also it's like perfectly normal. Hope that you enjoyed the video, and I'll talk to you guys later.